Hi, welcome to the Shiko Math Lab. So in this lab sections, we are going to take a look how to find the volume of a cap of a sphere. Okay, so let's take a look. So here we have the sphere, and we have the cap on the top of it. And the height of this cap is h, and the radius for this sphere is is r's here. So we are looking for the volume on the top here. For this province, this one is really kind of it's like the pretty easy ones here. So if okay, so if the same way, oops, here, let's see here. Okay, so if we can put a x-axis here, and then we can have a y-axis go down like that, right? And then we know from here to here, this is what? This is the radius r, right? And then this is the radius. This is kind of like the radius, the cross section for the top here. So for this ones here, then like in here, this is the height. Let me color in a different one. So this is the height, right? So this height, what is the height here? This height, the distance here is r minus h. That means it's in here, r minus h, right? So this cap, if you take a look, let me put in the 2-dimension for you. Okay, so this is the circle, right? So so this is the circle, and the cap is kind of like this circle. If you are like rotating along the y-axis here, if you are rotating along the y-axis, look here. So look for these areas here. All right. So this area, if you are rotating around the y-axis, so what is going to be? It's going to be generate what? It's going to generate this cap here, right? So if for this area, I'm rotating around the y area. Okay, so now we know if I'm rotating, I can use what? The slice methods, right? So when I slice it, I will get what? So if I use the slice methods here, so you will get so if I slice here, you will get what? Circles, right? So we'll get circles here. Okay, so now in here, let's take a look at how do we do it. So we said we know from here to here, this is my radius r, correct? And now for here, this one's here is so this point here will be what? Will be the 0 and the r minus h, right? And this point here, because this is on the circles, right? So this will be x squared plus y squared equal to r squared. Since we recognize the cap was generated by rotating this area on top of the circle. So I know the cross section, I can use the disk method, and the cross section is what? The cross section is it's a circles here. So right, so the volumes here will be. So volumes here will be you integrate pi r squared. Okay, so pi. So what is the r? Right, so this is so like here, this is the so this distance here, take a look here, let me see here, let me get a okay, so this distance here is my r, right? So when I'm rotating here, so what is this is x, right? Because I'm rotating around the y, so that's what I will get here. So the x here is equal to what? X equal to the r squared minus y squared and the square root. So that's why when I do that, so I'm just pi r squared. So this will be square roots of the r squared minus y squared to the square. Then I'm going to integrate to the dy. So what is the y value here? The y value is what? Is from here to here, right? So from here to here, so we know that this point is 0 to the r/2. So what is this top point? The top point is 0 to what? It's r's, right? So what is my upper and the lower bound here? I'm going to integrate from r minus h to r. So the concept is pretty easy. Then the algebra is a little bit tedious, right? So let's put the pi out. So this is r minus h to the r. So this is r squared minus y squared dy. Okay, now let's try to just do the algebra part. So this will be what? This will be the pi's, right? So this one's integration will just be r squared y minus y cubed to the third. Then what is my upper and the lower bound here? Is r and r minus h, right? Okay. So now in here, I can just substitute here. So this is the pi. So this will be the r, substitute the r into all the y's here, right? Okay. So now this is r to the what? Cube minus 3r to the cube, correct? And then minus, you substitute the lower bound. So this will be the r squared, r minus h, and minus, right? So minus 3, this is r minus h to the cube here, okay? So now that's just kind of like the, okay, so it's kind of like a simplified. It's just remaining just the algebra part. So r cube minus r cube over 3, so it's a 2/3 r cube, right? And then in here, I can factor the 1/3 out, so I don't have, the fraction to deal with. So if I factor the 1/3, also I can factor the r minus h out, right? So this is 1/3 and the r minus h. If that, what I have left here will be, because this is don't have 3, so I factor 1/3, so I need to have 3r squared. Then minus, then the other term will just be the r minus h to the square. Okay, so now let's just do, so now I have another 3 here. I can factor this one out. So it's pi over 3. All right, so then this is a 2r cubed minus r minus h. And then in here, I can FOIL that. So this is 3r squared minus r squared plus 2r h minus h squared. Okay, right? So now let's see anything I can combine. Oh, 3r minus r squared. So these two I can combine to the 2r squared. Okay, and now I just okay. So this one's here, this is a 2r. Okay, so now basically you just use the FOIL and to FOIL the whole things out, use distributive property to FOIL the things out, right? So this one's here, I'm going to have a minus 2r cubed minus 2r squared h plus r h squared plus 2r squared h plus 2r h squared minus h to the cube. Okay, so now let's see here. So we have here 2r. Okay, so a lot of things we can cancel. So finally, I have a pi over 3. And then I have a 3r h squared. All right, so let's see here. We can cancel here, right? So this one, we can cancel. And 3RH squared, this one and this one, I can combines, right? Okay, good. And then here, negative 2R, 2R's, oh, I'm sorry here, okay, so let's I kind of make a mistake here, right? So 2R square H, 2R square H, okay, 2R square H plus 2R square H. All right, so this one, I need to be careful here. So this one I can cancel. So I have R H square. So these two, okay, these two I can combine. Is 3RH squared, right? And then the last term, so yeah, okay, finally get it combined correctly, minus h to the cube here. So if you like, you can factor the h squared out, and then this is 3R minus h here. Okay, so or some people, if you want to put the 3 back inside, so this will be pi h squared. Then if you move the 1/3, this is r minus h over 3. Okay, all right, that's it. So for these problems here, so let's kind of like take a look at what we learned here. So for this ones here, right, because we know the cap here is just similar, like you have a, the square, the circle, then this area, this yellow area, you kind of rotating around the X. And so when you're rotating around the X, it's going to, see here, that's what, when you're rotating, it's going to generate, right? So that's why here I put the notations here, right? So I put the notations here is rotating along the y-axis here. All right, like I said, the whole concept is super easy. The setup is pretty easy, right? So the setup is just the pi r square setup, right? Because it's a disk, right? So pi r square, then just recognize the lower and upper limit. All right, that's it. I hope that this one will help you to do some of your volume problems here. All right, okay, so looking forward to go to our next lab and see what type of problem we can work on our next lab. Okay, have a good day. Okay, bye-bye.